All right, this video is to help complete the square or change an equation from standard form into graphing form by completing the square when our coefficient in front of the x squared is only a 1. So we're going to show you how to change this into graphing form, also called vertex form, and find all those special points like the x-intercepts, the vertex, line of symmetry equation, and all that other stuff. So here's an equation we're going to start with. This is in standard form. And the first thing we're always going to do, whether there's an a in front of here, or number in front of here or not, we're going to move this constant term out of the way. So I'm going to subtract 8 from both sides. So now it's on the side with the y. Right? So we move that constant term first. The next thing is I have 6 x's. Remember, if we made the generic rectangle or the square from Algebra 1 and earlier in the year, we split these 6 x's into 2 equal parts and into the box. So I'm going to do that kind of in my head. I'm going to take half of 6, maybe I'll just write that off to the side, half of 6, which is worth 3, and then I'm going to square this number. Okay, so that becomes a 9. And that's the number I'm going to have to add right here next to the 6x in order to make this right here a perfect square trinomial and factor so the sides are exactly the same on that box. So that's why we have to figure out what this number is. So I added 9 on this side because I took half of 6, which is 3, and then I squared that number. So that would be a 9. That's what we're missing up here. To keep my equation balanced, I also have to add 9 onto this side. So I'm going to write plus 9 over there. Okay, so now let's combine our terms. On the left side, we get a positive 9 minus 8, so that'll give me a y plus 1 right here. And now I'm going to factor this, and this is a perfect square trinomial, which means if you make the rectangle or make the box, right, this was a x squared, 3x, 3x, this is really small, I'm sorry, but this is the same thing that we have here. This is the area as a sum. We're going to write it as the area of a product, which means the sides are exactly the same. They're both x plus 3. And since they're the same, I'm just going to write it once and write it squared. And how we're doing this so quickly is we're just taking half of this middle number, and that's what's going in the parentheses down here. So we're always just taking half of 6 or half of whatever this x term is. That's what ends up going in our parentheses squared, since those are the outsides of our box. So last up is I want to move this 1 over. I don't want this to say y plus 1 equals. I want it to say y equals. So I'm going to minus 1, and I'm just going to minus 1 on the end of here, not inside the parentheses. Okay, I can't touch anything inside those parentheses anymore. So here's our equation in graphing form. Y equals x, or the quantity x plus 3 squared, then minus 1. So this should be the same exact graph as what we started with up here. Okay, so that's our graphing form. Let's find the vertex since we're here. Vertex is we take the opposite of this first number right here, opposite of 3, so it's going to be a negative 3. And then I keep the second number the same, negative 1. So there's my vertex. And maybe box that in. Let's find another one that's pretty easy to find is the y-intercept, especially if you're given this equation in standard form. So the y-intercept, I'm going to plug in x equals 0. Plug in x equals 0. So if we do that into our original equation up here, that's always just a safe bet, going back to the original to find things in case your equation's wrong here. So I'm going to plug this in. I'm going to replace this. So I have y equals 0 squared plus 6 times 0 plus 8. So this first part drops to 0. This turns to 0. I just have a positive 8 left. So my y-intercept is 0, 8. And that's always going to happen if our equation is in standard form. It's just that constant term on the end because we're plugging in all the x's to be 0. So everything else will drop out except our constant term. Let's see, something else here we can find from these things is our line of symmetry equation, or the axis of symmetry. I'm going to put LOS for line of symmetry and then just an E next to it because we're writing the equation of that. It's always going to be x equals something, and it's going to be the x coordinate of your vertex. So think about your vertex as the lowest point usually, or it could be the highest point if this opens down. And your line of symmetry goes straight through there, so vertically through negative 3. So there's our line of symmetry equation. Make sure you have it as an actual equation here, not just the number negative 3. Last step for this problem is to find the x-intercepts. And what we're going to start by doing is seeing if we can factor the original problem, which up here was x squared plus 6x plus 8. So I'm going to factor that into things that multiply to 8. Could be 8 and 1, but I'm going to do 4 and 2. 4, 2, because those things will add to be 6, and I wanted a positive 6 when I add them, and a positive 8 when I multiply, so those would re-multiply back to 8 on the outside, the inside, and the outsides, I'm sorry, I meant the last numbers. The 2 and the 4 will get me back to the 8 that I wanted. This will give me a 2x, this will give me a 4x, and if I add those together, I get 6x. So this confirms what we wanted. It is factored correctly. Now I want this to equal 0 because for my x-intercept, I want my y to be 0. Plug in y equals 0. So just like we did with the y-intercept, I'm plugging in the opposite letter to be 0. So I set this equal to 0. Well, in order to do that, either this quantity has to be worth 0 or this one. Right? Something times 0 would get me 0. Doesn't matter which one. So I set each of those equal to 0, and those will get me the x-intercepts. Okay. So I'm going to minus 2 from the first one, so I'll get x equals negative 2, x equals negative 4, and let's write those as coordinates, so negative 2, 0, and negative 4, 0. So what you could do now is go ahead and plot all these points and graph your parabola. So there's our first example. I'm going to erase this now and show you a new one that is a little bit different. Something to do that you can make sure your answers are correct if you're able to use a calculator. On some of our tests, there's no calculator part, but if you can use a calculator or when you're working on these problems, you can graph the original problem in your calculator where it says y equals, and you can graph your new equation in graphing form and see if they're the same. Check the tables, see if they're the same. Okay. Alright, so we have another example here. I'm going to show you another one that also factors. So let's first change this into graphing form. So I'm going to move my constant term over. X squared minus 9x. Okay. So again, I need to find a number that I'm going to add to each side. It's really supposed to be added here. That's where we want it to be. But since to keep my equation balanced, I need to add it to both sides. So in order to find that number, I'm going to take half of my x's, so half of negative 9. Keep that negative there. Half of negative 9 is negative 4.5. Okay? Or you can leave it as a fraction. Then I'm going to square this, including my negative, so it'll be a positive number in the end. And that's going to turn into 20 and 25. 20.25 there. So that's what I'm going to add over here. I'm adding it because it's positive, okay? If this were resulting in a negative, which wouldn't happen since we're squaring it, so I'm always going to be adding this number over here. But that's y. And then since I added to 20.25, I'm going to do the same thing over here, add 20.25. Okay, so let's combine our terms on this left side together. 20.25 minus 18 is going to give me y plus 2.25. Okay. Then I'm going to factor this side. Again, this is a perfect square trinomial. My box is actually a square, so the side lengths are equal. So I know it's going to be an x and an x would be in my quantities, but I'm just going to write it twice and write it squared, or not write it twice and write it squared. And then I'm going to take half of this number again, because that's where we're getting this from. We split the negative 9 into 2 equal parts, so that's going to be negative 4.5 right here in our parentheses. Last step is to move this 2.25 over. So x minus 4.5 quantity squared minus 2.25 is graphing form for that original equation in standard form. And from here, let's find the vertex, which again is the opposite of the first number, so it's going to be a positive 4.5. Keep the second number the same, negative 2.25. There's our vertex. Line of symmetry equation, or axis of symmetry, is always going to say x equals, because it's a vertical line going through all of the x values at one number, and that number is 4.5. Just the x part of the vertex goes straight through the vertex. So there's our line of symmetry equation. Let's switch gears to find the intercepts. Again, an easy one is the y-intercept, which is when I plug in x equals 0. So all of these, this drops to 0, this turns to 0, I just have an 18 left over. So 0, 18 is my y-intercept. And my x-intercept, let's see if we can factor this. Can you see that? I'm gonna move that up a little bit. So things that factor to get me 18, or things that multiply to 18 could be, oops, that's not going to work, I don't think. So 18, things that multiply would be 18 and 1 and 9 and 2. So that can't get me a 9 anywhere. So I'm going to have to either use the quadratic formula. Let's maybe go ahead and do that. Or let's use our equation here in this graphing form. So I'm going to set my equation equal to 0, because that's how we normally start with, to find the x-intercepts. I plug y equals 0. I'm going to move this 2.25 over, equals x minus 4.5 squared. Okay. You could also use the quadratic formula. I'm just seeing what would be something that you don't know how to do, possibly. So I'm going to take the square root of 2.25, and let me see here. This works. I think I know, just want to double check. That doesn't work. 1 second here. All right. Got 4 calculators in this room, but none of them have batteries. Okay, 1.5, just making sure. Don't want to do it wrong. So positive 1.5 equals, this is just an x minus 4.5 left over. And it's not squared anymore because the square root was the opposite of it. Or I could take the square root of 2.25, and technically I could get negative 1.5 equals this quantity here. Okay, because if I square 1.5, or if I square negative 1.5, I'll get back to positive 2.25. So that's how we're going to get 2 different answers for our x-intercepts. So if we add a 4.5, add 4.5, I'm going to get x is worth 6. And if over here I add a 4.5 and add 4.5, I'm going to get 3. Okay. Oh, oh my gosh, that actually was factorable. You see that now, that I get x is 3 and x is 6. I was kind of expecting to get more fractiony or decimal answers, since I was thinking it couldn't factor, but we get x minus 3, x minus 6, doy, and then set those equal to 0. So, okay, that was good. I guess I showed you the other way. But it did factor. You probably realized that, and you're thinking, oh my gosh, Miss Stastny is cuckoo. But this is how you can solve it if you cannot factor the original expression or original equation, or you can always use the quadratic formula, which you're probably more familiar with that. So hopefully this helped you realize how to do it the other way. So now you can work on that worksheet, hopefully get some more practice on completing the square and finding all those special points.